Hi everyone, welcome to AI Exact channel. This is Akash Angbar and today we'll be studying straight lines lecture 1. So let us start off with Cartesian coordinate system. Let's say we have this point A over here and let's say the coordinates are x1 and y1. I have written it casually, but let me explain it what they mean actually. So this is x-axis, this is y-axis and this is our origin. Now x1 means the distance from the y-axis, the horizontal distance from the y-axis, basically perpendicular and horizontal, distance from y-axis to this particular point is x1. Basically, this length is x1. Now, similarly, y1 is vertical distance from x-axis till this point, that is y1. This length is y1. Now, it can be negative as well. It can go over here as well. Let's say we have a point 2 comma minus 3 over here. So basically this distance for this particular point, this distance is 2 and this vertical distance is minus 3. Not distance, basically the coordinate is minus 3, distance is 3 only. So because it's below x-axis, that's why it's negative, but the distance is 3 with the negative sign. Okay. Now let us talk about polar coordinate system. So in this case, we define a particular point with the help of r comma theta. So what is basically r? R is the distance from origin. This is origin, this is x-axis, this is y-axis, and theta is the counterclockwise angle, basically inclination of this particular line with respect to x-axis in the counterclockwise direction, right? So let's say we have this xy x-axis, x and y-axis, and these all are r distances. This is r, this is r, this is r, this is r. So why have we defined theta as well? Because if I have to define the particular point with respect to just r only, in that case we can have multiple points, right? Because r can be anywhere. It can point out anywhere with the distance r. But if we have to fix a particular point, then we have to define the inclination. So when I have defined the inclination theta, then in that case this point becomes fixed. So we won't be having any multiple possibilities over here. Now let us see the interconversion of these two coordinate systems. So this is our, so this is my x-axis, this is y-axis. This is point r comma theta. This is theta, this distance is r. Okay. Now this distance is, let's say, a1. This distance is b1. I can clearly say that this a1 distance would be nothing but r cos theta, and b1 distance, basically this distance is also b1 because this is a rectangle. b1 would be r sine theta. So this is how we have to convert, interconvert Cartesian into polar or vice versa, right? Now let us talk about distance formula. So let's say we have this x-axis and y-axis, and we have these 2 points A and B. And now what I want to do, I want to find out the distance between these 2 points, basically the length of AB line segment. If I want to find out the length of this line segment, then how to do that? Let's say A has the coordinates x1 and y1 and B has the coordinates x2, y2, right? So this is x2, y2, this is x1, y1. Okay. Now I'll start dropping perpendiculars from these points, and I'll drop one perpendicular from A1 to the perpendicular from B1 to x-axis. Okay. Now these all are perpendiculars. Now I can clearly see that this distance is x1 and this distance is x2. So basically this distance is x2 minus x1. Similarly, this distance is y1 and this distance is y2. So basically this distance would be y2 minus y1. Now in this triangle AB, and let's say this point is C. So in this triangle ABC, I can apply Pythagoras theorem. So basically AC square plus BC square equals to AB square. So AB square is nothing but the distance which you want to calculate. So AB would be under root AC square. AC square would be x2 minus x1 whole square, and BC square would be y2 minus y1 whole square. So this is our distance formula. So whenever we have been given 2 points x1 y1 x2 y2, then this is how we have to calculate the distance. Now let us talk about the section formula. Now let's say we have, and we are first talking about the internal division. So let's say this is point A, sorry, this is point A and this is point B. Coordinates are x2 y2 and here coordinates are x1 y1. Now there is one point called C and the coordinates are x comma y. Okay. Now I want to find out the point, and this ratio is m is to n. So basically this C point is dividing the line AB into ratio m is to n. Now with the help of this information, I want to find out the value of x and y. Now how to do that again? I'll be dropping perpendiculars. Now let's say this angle is theta. This is ABC. Let's say this is D. This is E. Okay. Now in trying, we can clearly see that this angle is 90 degree. This angle is 90 degree because these are perpendiculars, and this angle is common. So the remaining angle, let's say this is phi, and this is also phi. So we can clearly see that the triangles ABD is similar to ACE. Right? These two triangles are similar. So what I can do, I can write CE divided by BD equals to AC divided by AB, right? Based on similarity properties. So CE over here is, what is CE over here? That would be y minus y1. This distance is y1. This entire distance is y. So CE distance would be y minus y1 divided by BD. BD would be y2 minus y1. Y2 minus y1. That should be equals to AC. AC is nothing but, let's say, m times k. I mean, let's say this is mk and this is nk. Ratio is m is to n. So I'm assuming that AC equals to m into some constant, and AB would be m plus n times k. That is nothing but m upon m plus n. Now we'll do the cross multiplication. We'll be getting y times m plus n minus y1 times m plus n equals to my2 minus my1. Now I can clearly see that this term gets cancelled out. So basically y times m plus n equals to m by 2 plus n by 1. So this would give me y equals to m by 2 plus n by 1 divided by m plus n. So this is our section formula for y coordinate. Now I can do the similar kind of calculations, exactly same calculations for x coordinate as well. Then I'll get, similarly I'll get the x coordinate as mx2 plus nx1 divided by m plus n. Now you can remember this in this format, that m is being multiplied by this left hand side ratio is being multiplied by a right hand side coordinate, and left hand side left hand side number, this m is being multiplied by right hand side coordinate, and right hand side number is being multiplied by left hand side coordinate. So this is how you have to remember this formula. I'll write it over here once again to make it more clear. Y equals to mx2 plus nx1 divided by m plus n, and x equals to, sorry, this is m by 2 n by 1. This would be mx2 plus nx1 divided by m plus n. Now let's talk about external division section formula. So let's say we have this line over here, A, B. So let's start with our discussion of internal division. So we had a point C over here, and this used to divide AC is to CB. equals to m is to n. This used to happen, right? M is to n. Now, what I'm doing over here in case of external division, I'm just pulling this c from here to an external location. So let me draw it something like this. This is A, this is B, and let's say we have a point C over here, which we have pulled it from here. So this point is C. Now again, over here it was AC is to CB. Similarly, over here as well, AC is to CB. So this ratio is M is to N, right? So this is the only difference between external and internal division. So now let's try to derive the formula. It looks very counterintuitive, but this is how it is. AC is to BC. So we have this A, and let's say B is over here and C is over here. Now this is x1, y1, this is x2, y2, and this is xy. Now we know that AC is M and BC is N. So this length is N. So basically this would be M minus N, and this would be N. So AC would be M, M minus N plus N would become N. So AC is N and BC is N only, right? Now we can think it in the reverse manner of internal division only, that B is dividing this entire line segment in the ratio of M minus N is to N, right? So what I can do, I can, with the help of internal division formula, I can write x2 equals to M minus N times x plus N times x1 divided by M minus N plus N, right? So this would give me, if I cross multiply it, I'll get mx2 equals to mx minus, sorry, I'll write it like this only, x times m minus n plus nx1. So this would give me mx2 minus nx1 divided by m minus n equals to x. So we have got this particular formula. Now you can clearly see over here that in case of internal division, it was mx2 plus nx1 divided by m plus n, but we have just replaced plus n with minus n. So in case of external division, the only difference is we have used the minus sign over here, and the remaining part is more or less similar. Similarly for y, that would be my2 minus ny1 divided by m minus n. Okay. Now the interesting thing is, while finding out the ratio with the three given points, if the ratio is positive, then it is internal division. If it is negative, then it is external division. So let's say we have given 2 points. This is A, this is B. Now we have some unknown point. It can be either over here, it can be either over here. Then how to find out if it's an internal division or an external division? So basically we'll do the calculations. And if the ratio comes out to be positive, then it means an internal division. If the ratio comes out to be negative, it means an external division. And one more convention we'll be following is, so whenever we are taking the ratio as the variable to find out, so basically we have to find out the ratio. So we have to take that as a variable. So in that case, we'll be taking A is to 1 and not M is to 1, because in this case, we'll have to deal with two variables. But if I write A is to 1, that would mean the same. Let's say 3 by 2 is to 1 is same as 3 is to 2. So we'll try to find out this fraction and convert into this particular format, rather than trying to write M is to N and then doing multiple calculations, right? So whenever we are assuming the ratio, we'll be assuming in this format, A is to 1 or lambda is to 1, whatever. Now let's look at this question. The line joining the points P 2, minus 3 and Q minus 5, 6 is divided by y equals to x in the ratio. So basically we have P somewhere over here and Q somewhere over here. And these are the points. And y equals to x line looks like this one. Now let's, and since this is y equals to x, we can assume that this point would be a comma a, right? Or whatever you want to name it, a comma a, x1 comma x1, whatever. But both the coordinates would be same, because this is a part of y equals to x, right? So this particular point would be a comma a. Now let's say this is dividing this entire line this in ratio. Now let's say this is dividing this entire line PQ in the ratio m is to 1. So m is to 1. So remember that thing. I'll be using m is to 1 rather than m is to n as a ratio. Now P coordinate is 2 comma minus 3 and Q coordinate is minus 5 comma 6. Now A would be, if I try to write the X coordinate with the help of section formula, then A coordinate would be M times 2, this ratio multiplied by this one, and 1 multiplied by minus 5. So basically minus 5 only, divided by M plus N. Here N is 1, M plus 1. And similarly, the y coordinate A, that would be M times minus 3. So minus 3M plus 1 times 6 divided by M plus 1. Now if I equate both of them, I'll be getting 2M minus 5 equals to minus 3M plus 6. And I've cancelled it out, M equals to minus 1. M, because M not equals to minus 1. I'll tell the reason afterwards. But this is not true. So that's why I've cancelled them out. So basically 5M equals to, this is 6. 5M equals to 11 and M equals to 11 by 5. So this is the ratio. Now let's say if I take M equals to minus 1, I might think that, okay, it might be possible to have an external division in this case and M equals to minus 1. Then what happens? Now if I look at the concept, this was A, this was B, and this was the point C. So AC divided by BC, it can never be minus 1, right? Because it has to be, AC is including the length of BC. In case of external division, AC is including the length of BC. So AC is always greater than BC, right? So it can never be equals to minus 1, because in that case, the length should be equal. But that is not possible because AC is always bigger than BC. So that is why M equals to minus 1 is not possible. If it was some other ratio, then we would have considered it. But in this case, we cannot consider it. Now let's look at this question. If P, Q, R, S are the vertices of parallelogram P, Q, R, S, then we have to find out the value of S, A, comma B. This is not mentioned over there. So let's try to plot the coordinate axis first. So this is x-axis, this is y-axis. Let's say this is our point P, and Q should be, this is 1 comma 2, and Q should be somewhere over here. That would be 4 comma 6. R should be somewhere over here, 5 comma 7, that is R. So obviously in such a case, S should be somewhere over here to make a parallelogram out of it. So we have this kind of parallelogram. Now one important property we are going to use over here is the diagonals, the point at which these diagonals intersect. It is the midpoint of both the diagonals. So this particular point divides this line into equal parts and also this line to equal parts, right? Now we can write the section formula in such a case in a different manner. So we have 1:1 ratio over here. So in case of M plus N, we'll be having 1 plus 1. So that would be 2. And in the, let's say this is x1 and y1, this is x2, y2. In the numerator, we had mx1 plus nx2. So that would be 1 times x1 plus 1 times x2. That would give me x1 plus x2 divided by 2. So basically, we have to divide the coordinates by 2, adding them and dividing by 2 to get the value of this particular coordinate with the help of section formula only. But you can remember this as the midpoint formula. Now, we'll do the same thing over here. Let's say this point is O over here. This is x comma y. So x is equals to 5 plus, with the help of P and R, x is equals to 5 plus 1 by 2, that is 3, and y equals to 7 plus 2, yes, 7 plus 2 by 2, that is 9 by 2, right? And using these two things, these two coordinates S and Q, we can get x equals to a plus 4 by 2, and that is 3. So basically a equals to 2. From here this becomes 6 and this becomes 6 minus 4, that is 2. Similarly y equals to b plus 6 by 2, b plus 6 by 2, and that is 9 by 2. So basically b equals to 3. So we have got our points 2 comma 3. Now let us talk about the area of triangle with the help of coordinates. Let's say this is our triangle. This is A, this is B, and this is C. Let's say this is x1, y1, this is x2, y2, and this is x3, y3, right? Now, how to find out the area? So for that, I'll be doing some constructions. So let's start dropping perpendiculars from all these points. So let's say this is A, B, C, this is D. Let's say this is E, F, and G. Okay. Now I can find out the area of let's calculate the distances first. So this particular distance would be x1 minus x2, x1 minus x2, because this is x1, this is x2, so this distance would be x1 minus x2. Now if we talk about this distance, that would be x3 minus x1. This is x1, this is x3, so x3 minus x1. Similarly, CE length would be y3, AF length, that would be y1, and BG length, that would be, sorry, this is y2. Yes, yes. BG length would be y2, right? Now what I'll be doing, I'll try to find out the area of this triangle with the help of trapeziums. So area of triangle, I can write the area of entire figure by trapezium ABGF delta plus delta trapezium AFEC, sorry, AFE and C, AFEC and ABGF. This is the entire area. And if I want to calculate the area of ABC, then I'll subtract the trapezium. This one, this I'll subtract this trapezium. That would be delta trapezium BCEG, BCE and G, right? Now, if I try to write it mathematically, then this area would be ABGF. ABGF would be half times sum of parallel sides, that would be BG plus AF. BG plus AF would be y1 plus y2 multiplied by distance between them, that is x1 minus x2, x1 minus x2 plus half times trapezium AFEC. AFEC, sum of parallel sides, that would be AF plus CE. AF plus CE would be y3 plus y1, y1 plus y3 multiplied by distance between them, that is x3 minus x1, x3 minus x1 minus half times area of trapezium BCEG. BCEG, in this case, the parallel sum of parallel sides would be CE plus BG. CE plus BG would be y3 plus y2 multiplied by distance between them, that would be x3 minus x2, x3 minus x2, right? So if I solve this further, what I'll get, I'll write it over here. I'll get 1 by 2 times x1 y2 minus y3 plus x2 times y3 minus y1 plus x3 times y1 minus y2. So this is the formula we are going to get if I am trying to open this up. Okay, so this you have to remember. Now one thing over here, sometimes what will happen, we have derived this formula by considering these points as cyclical, by placing them at the right place, right? X1 y1 is this one, x2 y2 is this one, x3 y3 is this one. We have derived this formula with this particular orientation. Now sometimes what will happen, you'll be given some points but you will not arrange them cyclically, and you will misarrange them. In such case, we'll get the answer is negative. There won't be any calculation mistake over there, but you'll get the answer is negative only. So you have to take the modulus of this entire expression, and then you have to report the answer for the area. So sometimes what will happen is they'll give some variables over here and they'll give the value of area over in the answer. Now you have to take two conditions. Sometimes you'll get the with plus sign, and sometimes you'll get the answer with the minus sign. So you have to take two conditions over there. Now we can also write our area in the determinant format. You have to remember this and this means the same. If you are going to open this up, then it will come out to be exactly same. So you have to remember in this particular format as well. So x1 y1 1, x2 y2 1, x3 y3 1 multiplied by half, and modulus as well. If whatever the value I getting over here, you have to take the modulus. So let's look at this illustration. Find out the area of the triangle having midpoints of the sides at 2, 1, minus 1, minus 3, and 4, 5. So I'll leave this question as the homework. That's a very simple one. There's just one single trick. So I'll just tell that particular thing. So let's say we have this triangle ABC and we have these midpoints over here. Now with the help of midpoint property, which we have studied back in class 9th or 10th, we can say that if these two are midpoints, then this line and this line is parallel. And so basically this triangle, let's say this is D and this is E. So ADE is similar to ABC. Now you have to utilize this concept to find out the area of the entire triangle with the help of these midpoints. The first thought would be, okay, midpoints have been given. We can solve three equations, three variables, and we'll find out the coordinates of ABC. And then we'll use the formula for the area with the help of coordinates. But that is not how you have to do in the examination. You have to use this similar triangles property, and you have to find out the area of this one and use that area to find out the area of the ABC triangle with the help of similarity. Okay. So today's lecture was till here only, and from tomorrow onwards, we'll start with the other topics of straight lines. And let's meet tomorrow. Thanks for watching.